So in this video, we'll look at where is the function f increasing, where is the function f decreasing. And if you're given the graph, I think the answer is pretty clear because, for example, please look at this purple line. And you see, if you imagine that you're actually traveling along this line, you're actually going down first. And which means before you turn up again, you're actually decreasing, right? Because you're actually going downward, right? So it's actually decreasing before you turn the direction up until this point, which is increasing. Then you go down again, which is decreasing. You see? So if you have a graph, it's actually quite easy to understand where you're going down and where you're going up. But now the question is that you're not given a graph. Are you able to find where is the function f increasing or decreasing based on the tool that you have with differentiations? I think now the problem is not that difficult. Why? Because you see, the direction that you're traveling, for example, like this graph on the left-hand side, what you're doing is you can just look at the arrow. You see, if you look at the arrow, what you have is a picture like this. These arrows represent what? These arrows represent the direction that you are traveling, which is exactly the tangent direction at those points, right? So this graph means what? This graph is actually the graph that represents the direction of the tangent line, and which means that we can actually use the sign table of f prime to attack this problem. So let me put it in words. It means when f prime is positive, which means the tangent is going up, is an increasing tangent line. It means at that point f is increasing. And on the other hand, when f prime is negative, which means the tangent line is going down, it means f is actually a decreasing function at those points. So based on these two hints, we can actually find the answer where is f increasing, where is f decreasing, based on the use of the sign table. For the first derivative f prime of x, and let's do some examples together now. We look at the current example of a given function f, and you are asked to find the x such that f is increasing or decreasing. So let's look at the first derivative. So the f prime is 6x squared minus 30x plus 36, right? And to find the critical numbers, we can set it 0, and I trust that you can do this calculation. And of course, you can take out the 6 as the common factor first, and then you can factorize it by yourself. After the factorization, we understand that there are actually two critical numbers. It's either 2 or 3. And from there, we can draw the sign table. So let's look at the current sign table for f prime, and we mark the two critical numbers 2 and 3 on the x-axis. And from there, you need to randomly choose 3 points in each interval. So for example, we can choose like 1, which is 2 in the left interval, of course, and it becomes f prime of 1. You need to compute that. And for the middle interval, you need to compute, let's say 2.5 for the f prime. And for the last interval, you can choose maybe f prime of 4, right? And let's do the calculation for these three values. So after finding the f prime at the three values you chose, and we notice that for the first value 1, the f prime is positive. For the second value, it is negative, and the last value, it is positive. So we can mark it on the sign table like positive, negative, and positive. And as a good habit, you can actually draw the arrow as the tangent direction for each interval. For example, the first one, it is going up for the tangent direction, and for the second one it is going down, for the last one it is going up. And basically the table of f prime is done. So to answer this current problem, whether f is increasing or decreasing, we need to focus on the f prime for each interval. For example, for the left interval and the right interval, the f prime is positive, which means that the f of x is actually increasing. So we can write it down here. F of x is increasing for the left interval, which is minus infinity to 2, or the right interval starting with 3. So it's 3 up to infinity. And similarly, For f of x decreasing, we note that the middle interval have the f prime negative, and f prime negative implies that f is actually decreasing. So we can write down the final answer as 2, 3 for f of x is decreasing, right? And that's basically the final answer to this problem.